Hello, my name is John Cutrone, and this is Lab 2 of the Charged Tapes Evenly Distributed Line Chart. The goals of this lab are similar to the last lab in that we electrically charge two pieces of clear tape, observe the interactions between the tape and other objects, quantify the amount of excess charge on the tape, and create an accurate simulation of the electric and gravitational forces based on an evenly distributed charge model. The charged tape possesses a net positive charge. The charge's tape charge is 1.03 times 10 to the negative 8 coulombs, and the magnitude of the electric force on the tape is 1.51 times 10 to the negative 3rd newtons, and the ratio between deficient electrons and atoms found on the tape is 1.88 times 10 to the negative. The main physics concepts explored are Newton's second law of force equals mass times acceleration, specifically with gravity, and Coulomb's law with electric force, net electric field, and however, a new physics concept that is explored in this lab, which is the electric field based on an R perpendicular from the center of a rod. Now that the charge is considered an evenly distributed line of point charges, it can be treated as an electrically charged rod, and it considers separation distance and the length of the tape. The procedure is the same as before, where we prepare two charged tapes, make an observation of the interaction between the two charged tapes and its interaction with a charged pen, as well as suspending one tape and putting another charged tape near it to see its interaction. As seen in the last lab, the two U-tapes repelled. The U-tape and the negatively charged pen were attracted, which meant that the U-tape is positively charged, and the suspended U-tape and held U-tape repelled each other at a separation distance of 0.006 meters. Some assumptions that can be made is that air resistance can be ignored, both U-tapes have the same amount of charge, evenly distributed, and that both tapes are considered a series of point charges, but only one observation location at the center of the top tape is considered for the electric. This is a simple diagram of the two tapes with different electric force and forces of gravity shown. The experimental calculations are the same as before, where the surface area of the tape and the surface area of an atom can be used to find the total number of atoms. The gravitational force on the U-tape is determined with F equals mg, and because the electric force is supposed to be equal and opposite, you can use that to find the charge of a single tape, except we use the new electric rod equation to determine that the charge is 1.03 times 10 to the negative 8. Then we can use that to calculate the number of deficient electrons and the ratio between excess electrons and atoms. The Python code constants shown are the electric field constant, the gravitational constant, the mass of the tape, and the new Q charge that we calculated using the new formula. The top left part of the code is used to find the electric field of the tapes. The bottom left function is used to represent all of the different dq charges and electric fields on the tape now that we're considering it as a line charge. And the right part of the code is a continuation of that, in addition to modeling specifics. The data versus model predictions. The left model shows what the point charge model was like in the last lab, whereas on the right that shows our new model with all of the green arrows representing all the individual electric forces from different point charges. Some discussion questions. What if you'd modeled each of your tapes as a single point charge like in the previous lab? Compare the estimated value of the charge from the previous lab to this lab. When using a point charge model, the charge of each tape would be 2.66 times 10 to the negative 9th. When using a line charge model, the charge of each tape would be 1.03 times 10 to the negative 8th, which means the line charge model displays a greater charge by a factor of 3.87. And they differ due to different aspects of each model where the line model accounts for multiple point charges at different points of a rod-shaped object versus one singular point charge. And it is more accurate because tape has charge distributed along its body rather than just charge. Some possible sources of error are mostly due to measurement or alignment, but also because the observation location is considered one point in the middle. And the conclusion is that line charge models provide a more accurate depiction of charge than point charge models.